Hello everyone, this is Farzana. In the last video, we have discussed about the atmosphere. I hope with that video you could understand what are the different layers of the atmosphere, how these different layers of atmosphere behave in terms of temperature, how the temperature changes in these layers, and what are the different phenomena we observe in these different layers. I hope that was very helpful for you. In case if you are having any doubts, you can post your doubts in the comment section. I'll answer those, or I'll try to incorporate those doubts in our next video. So let us start with our this video. In this video, we are going to discuss two important topics. These are small topics but important for our understanding of climate, how the climate occurs, and what are the different aspects of the climate that are influenced, or what actually runs the climate. This is what we are going to discuss today. So these are two topics that we are going to discuss today are insolation. Our insolation, and first topic we are going to discuss is insolation, and the second topic that we are going to discuss is heat budget. So insolation and heat budget are the two topics of today's video. So let us start right away. So our first topic is insolation. Let us start right away. So insolation, as we know, first we'll see what does insolation stand for. Insolation, IN, is incoming solar radiation. IN stands for incoming. IN stands for incoming, whereas SOL stands for solar. SOL stands for solar, whereas this ATION is taken from the word radiation. So this ATIN is taken from radiation. So this incoming solar radiations acronym is nothing but insolation. So this is the sun's energy or sun's heat, sunlight received on the earth's surface. So this is insolation. So let us start our discussion. So we know that on the earth surface, earth is surrounded by the atmosphere. So this is our atmosphere that is surrounding the earth's surface. Now the solar radiation, they come in the form of short waves. Solar radiation enters into the earth's surface or reaches the earth's surface in the form of short wave lengths. These are short wave lengths. Now for every square meter of the area on the earth's surface, on an average around 240 watts of energy is received, that is solar energy is received. For every square meter of the area, 240 watts of solar power is received. That is why we see that these days many countries are showing lot of interest or keenness in increasing the solar power. India is not an exception for that. India, we know that we have various programs, and we have one particular program where we have, which is known as National Solar Mission. So under this National Solar Mission, we aim to increase our solar power generation to 100 gigawatts, 200 gigawatts by 2022. So we are aiming at increasing our solar power generation to 100 gigawatts by 2022. So and apart from that, the other very important aspect of this solar power generation in the context of our country, that is India, is the Prime Minister's keenness and his enthusiasm to start an alliance which is known as the Solar Alliance. So this is a solar alliance which has been started by the Prime Minister of India. So these are very important steps taken towards harnessing the solar energy. So what will happen is, if this amount of solar energy is harnessed, the dependence on the fossil fuels can be reduced drastically, which can help us in controlling the climate change. We know that there is global warming, and because of global warming, the average temperatures on the earth's surface are increasing. So this is detrimental to the entire life existence on the earth surface. So what we can do is we can go for renewable energy resources. So solar energy is that kind of alternative. So please, we have to remember that the solar energy is available throughout the year, especially when a country is lying in the tropics. So if a country is in the tropics, the amount of solar energy received is much higher than the country which is lying uh, in the higher latitude areas. We know that earth is spherical. Earth is spherical. Because of this, what happens? The amount of solar energy received is different at different places, and it is also tilted. Because of this, the amount of solar energy received is different. So in this process, what happens is, because of this spherical nature of the earth and the tilt of the earth, the tropical regions, they receive vertical solar rays. So these vertical solar rays have higher energy. So these tropical areas can harness this solar energy for generation of the electricity. Now we know that in India itself, if we see, in India we have the sunlight for almost for 365 days. That is, for the year round we have the sun. So we can harness this, and this can help us to reduce our dependence on the fossil fuels, and hence reduction in the release of these greenhouse gases. So let us come back to our topic, that is insolation. So Earth receives the solar rays as short waves. So Earth receives the solar rays or solar radiation in the form of short waves, and every square meter of the Earth's surface on an average receives 240 watts of solar energy. So the solar energy is received in the form of short wavelengths. So this is about insolation. So insolation is incoming solar radiation. Now, the other topic that we have to discuss is heat budget. What is heat budget? So whatever solar radiation is coming into the Earth's surface, it has to go back into the outer space. So the balance between these two is known as the heat budget. So a balance has to be maintained in order to have the optimum temperature on the Earth's surface. Now you know that Earth is the only planet in the solar system. Until now, whatever discoveries we have made in other galaxies also, in other systems also, whatever the discoveries we have made, we know that none of the planets match the Earth's position in the solar system. So Earth is located at a very important strategically. It is strategically located where it has optimum temperature for the existence of life on the Earth's surface. This position is known as the Goldilocks zone. This zone in which Earth exists is known as Goldilocks zone. So here we have optimum temperature for the life to exist on the Earth's surface. So so why does the life exist? Because of the temperature, optimum temperature. Just imagine that if this is not there, and just like other planets, our Earth also has, whenever the Earth sun one side of the sun or part of the Earth is facing the sun, the Earth might be having very high temperature, whereas the other part which is away from the sun would be having very low temperature. So these two are not conducive. These two conditions are not conducive for the life to exist. For life to exist, we need to have optimum temperature. So what is the temperature of our Earth's surface? The average temperature of our Earth's surface is 15 degrees Celsius. 15 degrees Celsius is the average temperature on the Earth's surface. So this is a very important temperature that we are having. So this is the average temperature. This is, we are not talking about any particular area. So when we go to the area specific thing, the temperature may vary. So Earth's average surface temperature is 15 degrees Celsius. Now in this diagram, you can see that there is some amount of solar energy that is coming inside the Earth's atmosphere, and some amount of energy is leaving the Earth's atmosphere. So the balance that is maintained in these two. So this is the incoming solar radiation, and this is the outgoing radiation. So the balance that is maintained between these two is the heat budget of the earth. Now it is, as I told you, it is very important to maintain the heat budget. Let us see how this heat budget is maintained. So here we are seeing that in the earth, 100% of the solar energy is entering, or solar insolation is entering into the earth's atmosphere. So this is the earth's atmosphere, and these dotted lines that you are seeing on in this figure are the outer space. These are the outer, so this is the boundary between the atmosphere and the outer space. So above this we have the outer space. Now the 100% solar energy is entering into the atmosphere. So when it is entering into the atmosphere, 16% of this solar energy is getting absorbed by water vapor, carbon dioxide and dust particles. So 15% of this, 16% of this is absorbed by water vapor, carbon dioxide, whereas 3% is absorbed by the clouds. And the 51% of this 100% of solar incoming solar radiation is absorbed by the land and the ocean surface, that is water and the land surface. So now this, apart from this, the heat that is absorbed or the radiation that is absorbed, some of it is reflected back, just like the light which falls on any surface. Some of the the light that is falling on any surface is reflected. In the same way, our sun's radiation that is coming inside the earth's atmosphere is getting reflected. So we will see how much is getting reflected. The air itself scatters back the sunlight or the insolation, solar insolation, or the short wave. So these are coming in short waves. So let me draw this. So these are coming in short waves. So the our air itself is reflecting back these shortwave light rays or shortwave insolation. This amounts to 6%. So this 6% of the solar radiation is reflected back by our, scattered back by our air itself. Now the clouds that are there, they reflect 20% of this solar radiation. It is very important. So clouds reflect, not only they absorb around 3% of the solar radiation, but they also reflect the solar radiation, that is, it is around 20%, and the rest is reflected, around 4% is reflected by the surface. Okay, the rest is reflected by the surface. Now here we'll pause for a moment and we'll discuss about when we are talking about reflection. So it is very important to understand a term which is associated with this, which is known as albedo. This is known as albedo. Now what is albedo? So if this is a surface, imagine that this is a surface. This surface, the sunlight is striking on this surface, and whatever is the sunlight is striking, it is getting reflected back. Okay, so this reflection back of the sunlight is known as albedo. So albedo is calculated on the scale of 0 to 1. So 0 is for those surfaces which have minimum reflection, that is, the reflection is least, whereas 1 is for maximum reflection. So for 0, the example would be black colored surfaces. For 1 would be white colored surfaces, like an area where the snowfall has just fallen. Okay, there has been snowfall, fresh snowfall. This area will reflect maximum amount of sunlight. So if we take in that context, so albedo would be maximum near polar regions, is it or not? So albedo would be maximum near polar regions. So the land surface, so the earth's surface, it reflects back around 4% of the solar radiation. So all this that is reflected back into the outer space accounts for 30% of the shortwave radiation that is be getting reflected back. So whatever is coming, it is sent back again. So this is this accounts for 30%. Now we know that some of it is getting absorbed. Here we have seen that some of it is getting absorbed. Now out of that, whatever is getting absorbed, out of that 21%, out of that 21% of the solar radiation that has been absorbed, out of that 21% is released as a long wave radiation or infrared radiation. So please remember that whenever the sun's energy is coming, we know it is coming in the short wave form. Sun's energy is coming and striking on the earth's surface in the short wave form, whereas when the earth gets heated up and it starts radiating the heat, or it starts reflecting the heat, it is in the form of long wave. It is in the form of long wave. So incoming solar radiation is in short wave form, whereas outgoing infrared radiation is in the form of long waves. Okay, so here the 21% of the long wave radiation is released into the atmosphere. Out of this, 15% is absorbed by carbon dioxide and water vapor. See here, please remember that carbon dioxide and water is not only absorbing the incoming solar radiation, this one, it is not only absorbing the incoming solar radiation, but also it is absorbing the outgoing infrared radiation, or it is also known as terrestrial radiation. It is also known as terrestrial radiation. So it absorbs this 15% of the terrestrial radiation, whereas only 6% is sent out into the atmosphere. The 7% of the heat is released in the form of sensible heat. So what is sensible heat? See, it is the when the air is lying in contact with the land, it acquires the temperature of that surface or land. Why? Because air is a bad conductor of heat, so it does not get heated up directly. It takes the property or the temperature of the surface on which it is lying. For example, if it is lying on a very cold surface, the temperature of the air would be very low, whereas if it is lying on a very hot surface, the temperature would be high of that air. So this is known as sensible heat. So this is also known as conduction. Okay, it is also known as conduction. So through conduction, 7% of heat is released, or infrared radiation is released, whereas through latent heat. So what is latent heat? It is convection. So what is convection? Or what is, we'll see what is latent heat. So what is latent heat? When you are converting something from one state to another state, the amount of heat required is known as the latent heat. So when you are converting solid into liquid, so what happens? You need to apply a lot of heat. So if you are melting ice, you need to increase the temperature, that is, you are applying heat, so it gets converted into liquid. Whereas if you are converting liquid into gas, so you need to apply more temperature, that is, water will get converted into water vapor, that is steam at 100 degree Celsius, is it or not? So this is latent heat. Or if we see it in reverse way, that is, water vapor is getting converted into water, then you need to remove the heat. The heat is removed. So in the same way, when you want ice, so what happens? You need to have lower temperature, that is, heat has to be removed from it. So the latent heat is the amount of heat absorbed or released during the conversion from one state to the other state, that is latent heat. So here in this is mostly convection that is happening. So what is convection? When the air gets heated up, we know that the air becomes warm, and warm air expands. As it expands, it rises. So as it rises, what happens? As it goes up in the troposphere, we know that in the troposphere, as we go up, the temperature falls. So what happens is the air that is rising, it reaches a dew point, and condensation will happen. Condensation will happen and cloud formation will happen. This will, and during this process, the water vapor, which is gaseous in state, it is converted into liquid or solid, that is ice. So here in this process what happens, heat is released. So this accounts for 26% of the heat. And even the carbon dioxide and water vapor, they also release the heat, especially water vapor, they also release the heat. So this is so here we can see that this all these when added, these figures when they are added, they form 70% of the heat released. So where is that the other 30%? It has to be balanced, right? Incoming is 100%, so outgoing has to be 100%. So the other 30% is coming from this place. So this 30 plus this 70 makes 100% of the heat that is lost to the to the space. So in this way our Earth's optimum temperature is maintained. So this is a very important aspect of our climate. So this insolation, it drives our climate. That is the phenomenon like evaporation, solar, this ocean currents and winds and all these things, rainfall, precipitation, everything is driven by insolation. So sun is the most important component of for the sustenance of life on the earth's surface. This we already know. That is why in ancient civilizations people considered people worshipped sun as god. So why? Because sun is essential for the existence of life on the earth's surface. So now coming to our this greenhouse effect. So we know that there are some gases which act as the greenhouse gases. These are known as greenhouse gases, like so carbon dioxide, sulfur dioxide, nitrous oxide, water vapor and all. So what they do, they absorb these. Here we can see here that they are absorbing the heat, they are absorbing the solar radiation. So in this way they are maintaining the earth's optimum temperature. Now where is the problem? Problem is we are adding large amounts of carbon dioxide, a nitrous oxide, sulfur dioxide into the atmosphere beyond sustainable level. So atmosphere has its own capacity, carrying capacity. We are adding huge amounts of these carbon dioxide, nitrous oxide, methane, all these things we are adding, which is increasing the temperature, average temperature of the earth surface, which is leading to global warming and hence climate change. So this is very important, because there was a news a few days back that by 2100 their polar bears would be completely extinct. So why do we have this kind of news? Because the Arctic would be ice free. Within few years the Arctic might be ice free during summers. So ice is very important for the polar bears survival, because it gives them shelter. And apart from that, the cold waters, they have huge supply of planktons which attract a large variety of fishes, which is the food for these polar bears. Last year there was a photo which was circulated of a starving bear. So these starving polar bear, so why did that condition come up? Because this bear could not find food. Why? Because planktons have come down because of increasing temperature. So these are very important aspects of our climate, and these are very important for our civil services examination preparation also. So I hope this video was helpful for you in understanding what is insolation, what is heat budget. I request you to share this video with as many people as possible, like and comment, and if you have any doubts please post it. I will try to incorporate in my next video, or I'll try to answer it then and there. So so I hope this video was helpful. Thank you for watching this video.